Hi, I'm Matt Scholz with the Sustainable Phosphorus Alliance, and I'm joined here today by Professor Vijay Chariar from IIT Delhi.
Hi, Matt. It's lovely to be here.
Yeah, it's great to have you here. And you're coming here today to talk to us a little bit about some of the research that has been inspired by the National Science Foundation's Phosphorus Sustainability Research Coordination Network. We'll also call it the PRCN.
That's right.
In the course of the discussion. Maybe you could tell us a little bit about your project.
So first of all, I want to say that it has been a great privilege to be part of a very distinguished set of scientists who are concerned with issues around phosphorus, who have come from across the world, worked together very closely over these last 5 years, exchanged learnings, created new outcomes. It has been a wonderful and joyous journey, and I'm very grateful to the NSF and to Professor James Elser, who has been very warm, welcoming, and created, I think, a beautiful synergy of many researchers working in very different contexts in different parts of the world to create a new impact on phosphorus research. We came to this group of people, lovely people, working on phosphorus in 2012, and my background has been more of looking at sanitation and water and waste. And very interestingly, there was a little piece of phosphorus in our research, and I think we have learned to look at that and value that aspect of research a lot more over these 5 years of journey, 2012 to 2017 with PRCN. India, as you know, very populous country, and we face a couple of challenges, even though our economy is booming, and probably also because our economy is booming and infrastructure needs to keep in pace with that. And sometimes a lot of the waste that we have in India and Indian cities gets dumped into some of our major rivers untreated. In fact, there are studies which say that 80% of our waste is going into our river bodies, which is actually 80% is going untreated, and that is creating an explosion of pathogens. It is also resulting in eutrophication, and the biodiversity is being affected, the water bodies are dying. So these kinds of situations were also existing in other parts of the world earlier, but at this time, 2017, it's a little complex situation to deal with, and so we need to understand phosphorus in this whole thing, actually. So there's phosphate, there's also nitrate, there is potassium, there is organics, and these need to be cleaned up, and they need to go back to what we call their own loops. So coming to the PRCN is very valuable because people are looking at it from a point of view of legacy phosphorus, and how phosphorus is vital for our bodies, and how there are different time scales of this phosphorus circulating in this giant ecosystem. So it has been hugely educative to interact with agronomists, soil scientists, limnologists, economists, technology people in phosphorus, chemists and physics people. So it's been very educative to look at it. And in fact, we have actually taken back many of the learnings by attending the PRCN meetings to our research back at IIT Delhi. And we are trying to also create impact on the quality of water bodies in India. So we call it crisis and opportunity. And when we look at the composition of wastewater, whether it is urine or grey water from the shower and the kitchens, or we look at black water, which is from the restrooms. There is a lot of nitrate, there's a lot of phosphate, there's a lot of potassium in there, and all that could be recovered, and there's a lot of economic value. And we actually find that urine is one of the elements where there's a huge amount of phosphorus. And so we have been advocating what we call urine separation, that in sanitation systems, if we could actually separate urine and fecal matter, then it becomes much easier to recover phosphate, nitrate, and potassium from human urine. Now, if you look at the large section of Indian population does not have access to good sanitation, the Indian government is working on programs to develop that. But what we say is that it's important to look at nutrient recovery technologies as we are promoting sanitation. If we promote more and more water-based sanitation, I think we're going to invest more energy to clean up the phosphate, nitrate, and so on. Rather than that, actually, it makes sense to recover phosphate, nitrate, potassium at source, in a decentralized manner. There is huge economic value in the nitrate, phosphate, and potassium in sanitation chains. So that is one piece of research that we have been focusing on. Globally, the human waste is 8.5 billion tons per day, and its economic value annually is said to be 20 billion US dollars. And the question we are asking our students, because I also interact with students on a daily basis, is asking whether this is waste or whether we actually need to look at this as actually as a resource, that there is resource there. Phosphorus, nitrate, and potassium in the wrong place, is waste. But if it is used, recovered, and reused, then it actually constitutes a resource. It can go back to actually make our farming much more self-reliant and sustainable. So coming to the PRCN has been very exciting. Along with Professor Rimjim Agarwal, who's been co-PI on this NSF-funded project, we actually created a global interactive classroom between IIT Delhi and Arizona State University. And students exchanged their context. So students of Phoenix were trying to understand food waste and how phosphorus circulates in the city and how to create a sustainable city. And they were sharing their ideas on phosphorus circulation and the food web with students of IIT Delhi who were walking along rivers and seeing waste being discharged untreated into rivers, and how the rivers were actually, the river quality and the water quality was getting affected. So this has been a very interesting aspect of the PRCN, is the student engagement. The other aspect was that we were very fortunate to get a very prestigious Peer Science grant, which is funded by USAID and administered by the National Academies of Science here in Washington, D.C. And as part of this International Water Management Institute, which is located at Colombo, IIT Delhi in India, and the Arizona State University, we all collaborated together over the last 3 to 4 years and worked on fecal sludge management, on urine reuse and phosphorus extraction from human urine. There were a couple of PhDs which were awarded. In 2016, one of my students worked on total nutrient recovery, of which a major component is on phosphate recovery. A student from Delhi University, again in New Delhi, India, worked on nutrient recovery from human urine and business models for that. A student is pursuing his PhD at UC Berkeley, Sharda Prasad, on fecal sludge management. And we are developing several business models on how we can actually look at fecal sludge management as a source of phosphorus and how we can recover phosphorus so that our ecosystems are much healthier. So we also have some very exciting news to share, in that the PRCN has actually been a shot in the arm for a startup that I incubated at IIT Delhi in 2013. So the baby, so PRCN was like what I should say, mother's milk for the startup that we incubated at IIT Delhi. So it has been very valuable. This is a sanitation technology startup, and phosphorus has always been something that has been interesting to us because of the potential of recovering struvite from human urine. So through Ecom Eco Solutions, which is our IIT Delhi startup, we have actually collaborated with a large number of organizations, both civil society organizations and industry bodies, to look at how can we make our water bodies cleaner, how can we recover nutrients from waste streams. And so I think interactions with PRCN have given us more fillip in our interactions with Indian industry and non-government organizations. So this is a snapshot of a wide variety of organizations we collaborated with as Ecom Eco Solutions, both in the US and in India, also a little bit in Europe, to try and generate ideas of what works well in different contexts. India is a developing country, booming economy, large population, big market. At the same time, our infrastructure and our environmental regulations and policies need to keep in place. So going forward, so we are thinking of creating an India working group on phosphorus sustainability, phosphorus recovery and reuse, and talk to a wide variety of players. So we need to impact policy, we need to increase the environmental consciousness of industry, and youth in general need to become ambassadors of understanding, the closing the loop philosophy, that there are these giant cycles, and the water cycle and the nitrogen cycle and the phosphorus cycle, and strengthening these cycles, and ultimately on commercializing some phosphorus recovery technologies, be they in the restroom or at city scale. So I think that it has been absolutely wonderful to be part of the PRCN, and I wish to place on record my immense gratitude to Jim Elsef. He's been a lovely collaborator. He's brought a diverse group of people together, social science people and technologists and economists. And I think all of us have become more enriched with knowledge about P. And I think going forward, we're going to stay in touch and take some of these outcomes to market and to impact, create more water abundance and create more nutrient sustainability on the planet.
That's great. That's very ambitious, and it's a very worthy goal. And I appreciate your taking the time to tell us a little bit about your program.
Thank you so much, Matt. It was lovely talking to you.
Yeah, thank you.